All right, epithelium, nervous tissue, muscle tissue. So your muscle tissues have one major purpose, contraction. Let's go down here. Whoops, there it is. Okay, so we had epithelium is covering. If you have a group of cells that work together to cover something, it's called epithelium. If you have a group of cells that work together for long distance communication, it's nervous. If you have a group of cells that work together to contract, that was the weirdest S I've ever written, and I write an S every day with my name. M-U-S-C-L-E. Contraction. They pull. Boom. It's a muscle. Muscle cells are designed so that they pull all the time. Notice I keep saying pull, I never say push. It's because muscle cells cannot push. They always pull and they contract. So if you think of like your arm, and I bend my arm like this, it's because these muscle cells are pulling. The bicep muscles up here on the top, they're pulling, they're contracting, and they're pulling these bones in my forearm towards me. But wait a minute, can't I push my arm away? Try it. Hold your arm like this, tighten your fist, and push forcefully away. It's this muscle. This muscle is now contracting. It's pulling, and it's pulling the back of my forearm like this, right? The muscle always pulls. When you have a bone, you always have a muscle on each side of the bone that opposes the other one. So if I'm pulling towards me, I use my biceps, but if I'm pushing away from me, I use my triceps, which are these muscles. Bicep, tricep. Always pulling. It's like a tug of war. They can both pull, but the one that's pulling hardest will win. So if my triceps win, I throw something, I push it away. My biceps wins, I pull it closer to me. You can see those in the picture here, the biceps on the top, triceps on the bottom. These are called skeletal muscles. Skeletal muscles always attached to what? There's a trick. Skeletal muscles usually are attached to what? Your skeleton. Right? So, skeletal attached to bones. But they can also attach to skin. This is the tricky thing. Your face. When I want to smile, I'm not moving. You can smile or frown without moving any bones in your face. So hold your mouth shut, smile, frown. Not moving my jaw or any bones, but these skeletal muscles are making my face move. So it can move your skin to make lots of facial expressions. Right? Can you do that on purpose, or does your body just do it? Can you smile if you wanted to? Sure you can. We call this a voluntary muscle. Voluntary because it means you can move it on your own. You have complete control over that. Okay? The next type of muscle is called cardiac. Guess where it's at? In your heart. Guess where else it's at? Nowhere else. They call it cardiac because it's only in your heart. When you think cardiac, you think of heart. Cardiac muscle, can you think for your heart to stop? Well, I hope you don't think of that, because if you did think of it and it actually happened, you'd die. So, can you voluntarily control your heart muscle? Can you tell your heart, beat faster? Beat slower? Not working. I'm not a ninja, which is a myth. The ninja just relaxes or whatever, and their heart rate slows down. Or you can get really excited about something, whatever, and your heart can actually start beating faster. But you're not directly controlling it. You're secondarily controlling it. So heart we call involuntary. Whoops. No control. Hey! So if I scare you, right, your heart beats a little bit faster. It's out of your control. You didn't mean for it to be faster, it just beats faster. Your pupils get bigger. Your breathing starts getting intense. That's your nervous system turning all these things up. and making your heart beat faster, and your fight or flight is what we call it, right? So involuntary, you don't have control over it directly. Next is smooth muscle. If you noticed in the picture, with the skeletal muscle, it's kind of rough because it has stripes. Cardiac muscle is kind of rough because it has stripes. Smooth muscle, no stripes, it's smooth. Smooth muscle is usually and this is going to be tricky because it's going to sound like epithelium, but it's usually a lining of an organ. You can have exceptions to the rule, but it's typically a lining of an organ. Like, when I say that, blood vessels. Okay, so it wraps around blood vessels. Or stomach. Can you think for your stomach to digest food faster? Can you think for in fact, all of the GI, except for the very beginning for swallowing and the very end for letting go of the stuff that's been processed. Those are voluntarily, hopefully, right? You can voluntarily swallow, you can voluntarily defecate. But all of your GI tract is lined with smooth muscle. It works on its own without being told what to do, right? The next time you have diarrhea, can you think, stop diarrhea, stop diarrhea? Or the next time you're vomiting, you go, just stop vomiting. Oh, all done, I'm fine. No, it's because your GI tract is doing something for some reason. And if you're vomiting or you have diarrhea, it's because it's trying to get something out of your body. You don't want it to stay in, it's better just to have it. I know you don't think that, but it's better to have it. So smooth muscle is always involuntary, just like cardiac. The only muscles you have control of are skeletal. This is tricky. Can you hold your breath? I can. What kind of muscle makes you breathe? Skeletal muscle. It's skeletal muscle that makes you breathe. The diaphragm that goes across the bottom of your lungs, the muscles in between your ribs, those are the muscles that expand your lungs to breathe in. They're skeletal muscles. When you go to sleep, you don't consciously think, breathe in, breathe out, breathe in, breathe out. You just do it on your own because your brain has been trained to know to do that, but you can intentionally stop until, and this is a fun one too, I've had students go, well, okay, I can hold my breath and then pass out, right? And I don't die, right? Because at the point where you pass out, your brain takes over and has that control. I'm hesitant to use the word involuntary, but it goes back into this normal control mechanism that makes you breathe again, right? So those are the three types of muscle. Where it's important for a microscope is looking at them. So we're going to start by looking at cardiac muscle, which is number 9. Number 9? Number 9? All right. So make sure your last slide is taken out and put back where it's supposed to go. We're going to look at number 9, cardiac. I don't know why I jumped right to cardiac. Oh, I missed it again. There we go. Number 9. Cardiac muscle. Already in the habit of this. I have my tissue. May as well just wipe it off now. A lot of times when I'm looking at slides, I'm looking at them late at night. My eyes get heavy. Okay, I'll come back to this tomorrow. So a lot of my slides have dust because I'll forget to take them out, which I know you're not supposed to do. I leave them in the microscope and I forget to cover my microscope, so I have to wipe my microscope down, clean my slides, or I'll pull them out and I'll put them on my book next to my microscope, cover my microscope, because that's usually the last thing in my mind, and then have to clean the slides later. Okay, make sure your stage is all the way down. Which objective should you have? Yep, the red, scanning, 4x. Gonna bring the slide in. Make sure our camera is on. I love that you don't have to mess with the phone. You can actually look directly. It's more fun to me looking directly, but I do like to take pictures, so it's good to have the phone there. Let's go to the scope. I know it's in the middle. I'm moving back and forth. I can see. Let's turn this up all the way. I'm going to go back. If you remember the first time that we talked, I said put a little mark on the side of your slide and focus on it. Well, there's the edge of my slide. See how that edge of glass, nice and clear? Look at the top of the glass. There we go. You can actually see some particles on it. I'm going to pull that back because I know my tissue's straight above. Keep pulling, keep pulling. There's the slide cover. I'm actually going to focus on that. There we are. Keep going, keep going. There's my tissue. Woo! This one's going to be fun to look at. So this is a slice of heart. I'm actually going to go right over here. I can already kind of see the lines, right? It's exciting. So I'm looking at this. My cardiac tissue, you can see, kind of goes in a straight line, but it has little lines that cross over the tubes. So I don't have solid tubes like skeletal muscle, where they go the full length. They kind of branch, and that's one of the characteristics of cardiac muscle, is it's branching. So if I write down, here's my physiology, voluntary, involuntary, involuntary. Here's my anatomy description. Okay, so here's my shape, and here's my function. So if we look at cardiac, I can say it has stripes and it branches. Two characteristics. So I want to look at it closer and get my image back up. Boom, boom. All right. So I'm going to go from scanning, turn it over. Now I'm at the 10x, which is 100 times total magnification. I know it's annoying to hear me say that every time, but when you put a 20x ocular lens in there, you have to start rethinking. So in this one, if I have the 20 in, and it says 100 or 10 down there, I have 200, not 100. All right, let's look closer. Oh yeah, I can see all the little nuclei, all the little specks. I kind of see gappiness in there. I'm gonna go one more. Excuse me. All right. Oh, kind of tough to see it. Let's see if I can dim the lights, get a little mood lighting here. Oh, big jump. Oh no, don't do that to me. My auto focus is brightening it up again. I don't want that though. Let's see if I can make some of the lines stand out. It's tough, but I can kind of see it. Still tough. Ooh, tougher. Ugh. No way. A little purple. Okay. So can you see it? I made it a little bit better. Let me show you. Can you see the lines that come like, here's a line right here. Here's another line here. Right, can you see that? Let's draw it. So I'm not going to draw all this. But down here I'm going to put a little cardiac. Cardiac at, oops. What do we have that on? 40. 40x times 10x ocular 400 total magnification, TM. Alright, and I see that line, it's like a tube there, kind of a tube there, and you would be better off switching to your 20x objective and seeing it more clearly, right? Let's see if I can adjust the brightness again. And I can see the nuclei in there. And there are a couple nuclei, little guys. Kind of here. Right now it looks almost like skeletal. I gotta find a branch. Boy, I should have found a branch before I started drawing this. I'm going to improvise. We'll say where I kind of lose the line, maybe it branches off this way. We'll say maybe it branches like that. Improvising some. These are improvised. If I do something like that, I want to make sure that I put a note on it. That's what I'm doing, because I didn't actually see that split. But I would see nuclei coming up here. Yep, and I'm missing one more important feature. And even your cartoon drawing is missing it. So normally, I would have kind of a little dark line going over. I could see the faint lines in here, but you see a little dark line here, maybe another little dark line here. These are called intercalated discs. They're calcified discs that go in between. So here, this one branches and goes up. Here's another one connected to it. It's cardiac. Let's switch over. You can look at the 20x, so you can always pause me and come back. I'm going to pull cardiac out. Put it in the box. Right back there at number 9. And I'm going to go for number 11. Skeletal muscle. Clean it off quickly. Good. I'm on my scanning objective. Ooh, did I just see 2? I did. Can you see that? Is yours exactly like that? See the 2 lines? So I'm going to put it in the middle. I'm going to start watching. Turn on my camera again. I'm still on purple. Oh, that's it. There's my normal. What is this? Oh. Scratched glass, that's what that is. Boy, I wonder if that's what I thought. Okay. That's my diaphragm. Let's see if I can touch it up just a little bit. Alright, I got my cleansing tissue. Oops. There it is. My lens cleaning tissue. Just gonna run it across. Did it change? Nope. I need to get some cleaner out. Still dirty. Uh-oh. I really hope that's not on the bottom side. Just might be. If that's the situation, I'm going to need a Q-tip that I don't have. So, since I don't have a Q-tip, I'm going to take my brush. This is a learning experience. Brush, wrap some of this cleaning, water up a little bit. Tissue paper. Darn it. If you're going to do this, Keep in mind that your objective is just loose in there, it can fall out. So don't do that unless you know what you're doing. So crumpling this up. I want to make it a little bit rough, but remember, even though it's crumpled up and rough, pull my objective out, it's still soft. So I'm going to go in here, give it a little cleany clean. A little bit better. So I'm going to put my slide back up, put my ejector back in, slide back on, and one more time. And turn my camera on. Swoop. Oh, look at that. Put it right onto the muscle. So that was kind of lucky. Cool. So here's why there are two strips. See how the top one and the bottom one look a little bit different? One of them, this one, is going into the muscle. It's going with the muscle length, kind of like if you look at a table, the lines in the table of the growth of the tree that the table is cut out of. If I'm looking down the table, this is the perspective. So at the end of the piece of wood, if I'm looking at the lines, it's this side. So let's go a little bit closer. I'm going to go for my 50x. Boom. I'm sorry, 50x. My 4x, my 10x. Fine tune. Boop. Oh yeah. Let's go back up. See how this looks. Yep. Looking good. All right. Let me explain for a second. So when you're looking at muscles, the skeletal muscle on the top there, they look like long fingers that are stacked. So you've got 4 muscle tubes, just like that, like my 4 fingers. They sit really tight next to each other. There's no gaps. It's not branching, kind of like you saw with cardiac. It's straight. You can see that one cell, which is the whole length, and that's just part of it, has multiple nuclei in it. Not just one, like we see with a lot of cells, but they're stacked, right? What if I cut the muscle cells like this and I looked at it coming this way? Right? It doesn't look like the flat, long pieces anymore. It looks like what we're looking at right now. We're looking into the length of the cell. So if I'm looking at a tube, let's say this is the tube, whoop, whoop, another tube, whoop, another tube, whoop. If I'm looking from this perspective, this way, I'm just going to see, here are my nuclei in here. If I look from this perspective, I see the nuclei from this way. Right? So the image we just had up is looking like this. So I have 2 images. I have the one on the top, which I'll go back to. Right here. is looking down the tube. I can see a little bundle of cells. Boop, boop. But when I go to the next one that's down below, they're long strips. So I can see stripes coming through. Let's see if we go to the edge, if it looks a little bit there. It's a really good spot to use. Right through here. Do you see them? You have sets of muscles that are going in order right along here. Let me see if I can clarify that a little bit. Nope. Right, next, let's go up to boop. Oh yeah. Right, so they separated a little bit, but I can see again. See this tube here? Another tube here. Another tube here, right? These two tubes almost look like they're connected. Another tube. So these are split out just a little bit. Still draw them. Right? So I'm going to do that. I have one that goes kind of along like this. And the line below it kind of goes like this. And then that one kind of separates right along here with the gap. You see what I'm seeing? And there's another one that comes right along here. Another one below that. They have a couple gaps. And then I can see these kind of squashed nuclei. There are three coming down here. 1, 2, 3. Because skeletal muscle, its feature is its long tubes. Okay. They also have stripes. So kind of the grayness of this is actually its stripes. And when you get to the 20X, you'll be able to see it. But the stripes go perpendicular to the length of the muscle. I'm not sure if popping up a filter is going to help me see it. Oops. Darn it. No, not really. Well, I was really hoping that purple would come through for us. It's not. Yeah. But once you get in the 20X ocular lens, you can see it a lot more clearly. Slide up. Yeah, again, you can see kind of the outline. Like right along here. You can see that cell that goes around. I can see the cell up here that kind of goes around. One down here. I see one here too, but it doesn't look like it has any nucleus in it. It does, we just happen to slice it off. Right? Smooth muscle is the last one, so we're going to go back to the scanning. We're going to pull this out. Put the skeletal back into its place, number 11. And then we're going to go to smooth, which is number 13.